Now in this part, we have -1 minus 4 times the cube root or the third root of 2x plus 72 equals -17. So we're going to be working with a different radical, in this case the cube root or third root. And I have mentioned before, when we're working with a different exponent, a different radical, then when we're raising it to a different exponent, we're going to be having different numbers. So let's start off with, I need to cancel off with my -1. So I'm going to add 1 to the left side, add 1 to the right side. So I'm going to have, on the left, my -4 times the cube root of 2x plus 72 equal -17 plus 1 would be -16. And then I'm going to divide both sides by -4 so I can get the radical by itself. So I'm going to still have the cube root of 2x plus 72 equal -16 divided by -4 will be +4. Now, I mentioned before that if we're working with different radicals, we're going to be working with different exponents, therefore using different numbers. Now, notice how I am consistent with my index, and the reason I'm bringing that up is because I have seen people, when they're working out this type of particular problem, it's easy to forget their index. So what I mean by that is, you start off with the cube root or a radical with an index of 3, but along the way, accidentally forgot the 3. So as they continue working, they thought that they were working with square root. So since they thought they were working with square root, they raised both sides by the second power. And again, when you raise it to the second power, you end up with a different number. So if I were to raise both sides by the second power, 4 squared would become 16. But again, I want to stay consistent with my work, so I kept the index, so that way I know I'm working with the cube root. Since I'm working with the cube root or the third root, therefore I'm going to raise both sides by the third power, so that way I can get rid of the cube root. Since I'm raising the left side by the third power, I'm going to raise the right side by the third power. So if I raise the right side by the third power, then it will be a different number, which will be 64. That's very different from 16. So now on the left side, since I raise the cube root by the third power, then what I have inside is simply what I'm going to write on the left side, 2x plus 72. After that, what I'm going to do is I'm going to solve just like a regular equation. I'm going to subtract 72 on both sides. So I'm going to have 2x equal 64 minus 72 will be -8. And then I'm going to divide both sides by 2 so I can solve for x. Then I'm going to have x equal -8 divided by 2, which is -4. Now, once I get my answer, I'm not actually done. I'm going to have to check if it works. And again, you need to check because sometimes the number you have might not work at all. So, I finished solving for x. I'm going to write my x value up here. X equals to -4. It's always best you check to see if what you found is a viable solution. So let me erase your work so I could have more room. But I'm still going to keep the original problem. This part right here. So I'm going to plug in -4 into this x. So everything else will stay the same. So -1 minus 4, the cube root of 2, and again I'm plugging in -4. So 2 times -4 plus 72 and is opposed to equal to negative 17. So I'm going to work on the inside. So everything else will stay the same. Now inside, 2 times negative 4 will be negative 8 plus 72. Inside the cube root equal to negative 17. Now inside negative 8 plus 72, that will become 64. So it's going to be inside the cube root. Then we're still going to have the outside number, negative 1 minus 4, and it's supposed to equal to negative 17. Then here, you can actually do the cube root of 64, which is 4. I still have that minus 4 on the outside and the negative 1. And again, it's supposed to equal to negative 17. Then here, I'm still going to do negative 4 times 4 first, which will be negative 16. Bring down the negative 1. Again, supposedly equal to negative 17. Now on the left side, negative 1 minus 16, that will equal to negative 17. And it matches with the other side, which is negative 17. So this answer will work. So I'm going to box that, and this will be my final answer. S equals negative 4. In this example, we are working with a rational exponent, which is the power of 1 to the third. So when it's, again, with a rational exponent of 1 over 3, then it's going to be equivalent to the third root. So whenever you see something that's being powered by 1 over 3, what's inside the parenthesis will be inside the cube root. So let's rewrite this problem with a cube root. So I'm still going to have the 2 on the outside, but inside the 2x plus 16 that's going to be inside will be the cube root, as you can see here, plus 5 equal to 1. Now the first step I'm going to do is I'm going to subtract both sides by 5, because I want to cancel out this plus 5. So minus 5 on the left, minus 5 on the right. So on the left I have 2 times the cube root of 2x plus 16 equal 1 minus 5 will be negative 4. From there, I'm going to divide both sides by 2. So on the left, I will still have the cube root of 2x plus 16 equal negative 4 divided by 2 will be negative 2. Now just like before, since we're working with cube root, you're going to raise both sides by the third power. Now over here on the left side, so to the cube root, raising by the third power, what I have inside is simply going to be on the left side, so 2x plus 16. Now on the right side, since I'm raising negative 2 to the third power, this is the part where you have to be extra careful. So negative 2 to the third power is essentially negative 2 times negative 2 times negative 2. Now if I were to do this step by step, I would do negative 2 times negative 2, which is positive 4. Bring down to negative 2. 4 times negative 2 will be negative 8. So when we have a negative number raised into the third power, it will be a negative number, in this case negative 8. So notice how inside the parentheses is negative 2, and I'm raising to the third power. Negative 2 to the third power is negative 8. Now we're going to solve just like a regular equation. What I'm going to do is subtract 16 on both sides. So 2x equal negative 8 minus 16 will be negative 24. And then I'm going to divide both sides by 2. So x will equal to negative 12. But again, I'm not officially done because now I need to check if it works. So I'm going to write this up here stating that I found that x is negative 12. And simply going to check if it works. Alright, so let me erase to make more room, but I'm going to keep the original problem, but in this case, I'm going to keep it with the radical, the cube root. So what I'm going to do is plug in negative 12 into this x. So everything else will stay the same. So the 2, the cube root, this 2 here, but again, I'm plugging in negative 12, so let me write that in. And then add in my plus 16, then bring down my plus 5, and the equal to 1. Alright, so let's work on the inside. 2 times negative 12 will be negative 24 plus 16 inside the cube root with the 2 on the outside, plus 5 equal to 1. Then simplify the inside of the cube root. So negative 24 plus 16, that's going to come out as negative 8 inside the cube root with the 2 on the outside, plus 5, and again, supposedly equal to 1. Then here, you're going to do the cube root of negative 8. Now, just like how earlier, if you raise a negative number by the third power, it's going to come out as a negative number. Same thing apply. If you're going to do the cube root or the third root of a negative number, most likely it will be negative. So the third root of negative 8 is negative 2. Bring down my 2 from the outside, plus 5 equal to 1. 2 times negative 2 is negative 4, plus 5, supposedly equal to 1. Negative 4 plus 5 is 1, which matches with the other side. So therefore, negative 12 does work. This will be my final answer. So when you're working with radical equation, or also known as equation with radicals, it's always best to check if the answer works. So even though that I mainly check for the cube root or the third root, it's best that you check with the square roots in case if it works.